Hello students, I am sure you are now familiar with the preliminaries of quadratic equations, and today's lecture let us see some problems of different type on the quadratic equations, and most of these problems have already appeared in the competitive exams like IIT entrance exam and IIT and other competitive examinations. Let us take a function f of x defined by a rational function mx square plus 3x minus 4 whole divided by m plus 3x minus 4x square, where m is a real number, m belonging to R. Now I want to see for what values of m this f is an onto function. F is an onto function. This is the problem we have. For this, first let me just recall. We know that the function, the terminology is here, the onto function. What we mean by onto is, if at all f is a function from a set A to another set B, we say f is onto if f of A, the image of A is equal to B, if and only if. Equivalently, if for every y in B, if we can find there x is a x in A such that f of x is equal to y, then we say f is an onto function. And also let me just recall what we did in the previous lecture. If a function is a, for instance, if a quadratic expression, let us say ax square plus bx plus c, this is greater than or equal to 0 and A is positive, that is the quadratic expression is greater than or equal to 0 if the discriminant b square minus 4ac is less than or equal to 0 and A is positive. Okay. So, assume that the given expression, this is non-negative, that is the graph of this function y equal to ax square plus bx plus c, that is lying above the x axis, if and only if the discriminant is non-positive and A is greater than 0, then the graph will be something like this. This is the x axis, the graph will be above the x axis, okay, or it can touch at some point, or it can be like this. Okay. So, these are the possibilities. And so, how do we proceed with this? So, let us take some y in R. To prove that it is onto, I have to take a point y in, because f is a mapping from R to R. Maybe let me be more precise. F is an onto function from R to R. Okay. Except possibly at the points where the denominator vanishes. Now consider take y in R. Now suppose there exists some x such that f of x is equal to y, then we say it is onto. Now we have to find how to find the x such that f of x is equal to y. So our aim is to find x in R such that f of x is equal to y. How does it follow? Let us consider this equation, that is mx square, the given expression mx square plus 3x minus 4 divided by m plus 3x minus 4x square is equal to y. We have to find a x such that this is satisfying this equation. Okay. Let me just cross multiply this m. So, if I simplify this, I get m plus 4y, let me write as a quadratic equation in x, plus 3 times 1 minus y into x minus 4 times 4 plus my is equal to 0. I cross multiply and I take everything to the left side and equal to 0. Now, for this quadratic equation I am looking for a real, I want a real x. So, I am for this quadratic equivalently for this quadratic equation we are looking for a real solution. For that the discriminant has to be non-negative. Okay. So, b square minus 4ac should be the discriminant d should be greater than or equal to 0. So, for this d should be, we want d to be greater than or equal to 0. So, let us take the d is equal to b square, that is 9 1 minus y whole square, b square by plus 4 m plus 4y 4 plus my. So, this is our d, and if I simplify this I can write in terms of the y, the quadratic equation in y. For instance, it becomes 9 plus 16 m into y square plus 46 plus 4 m square into y plus 16 m plus 9. Okay. So, one can verify this, you just expand this and you can write in terms of a quadratic equation in y. Now, we want this to be greater than or equal to, we want this to be greater than or equal to 0. This is a quadratic equation in y and we want this to be greater than or equal to 0. Now, I look at this condition, any quadratic expression is non-negative if and only if its discriminant should be less than or equal to 0 and a is positive. For this quadratic equation to be greater than or equal to 0, so we need to have its discriminant according to this condition, the discriminant has to be less than or equal to 0 and a is positive. So, for this to be greater than or equal to 0, we have to have 9 plus 16 m should be greater than 0 and the discriminant, that is the b square minus 4ac of this quadratic expression in y, that is b square, that is 46 plus 4 m square whole square minus 4 times, that is 9 plus 16 m whole square should be less than or equal to 0. Now, if I simplify this, I end up with 16 times m square plus, that is I can apply the formula a square minus b square is equal to a plus b into a minus b, then it becomes 16 into m square plus 8m plus 16, one factor, and another factor is m square minus 8m plus 7 less than or equal, this we have to have less than or equal to 0. That means this, now you look at this, these are simple quadratic expressions. So, this turns out to be m plus 4 whole square and this one is m minus 7 m minus 1. Okay. This should be less than or equal to 0. So, this is anyway non-negative, m plus 4 whole square for any value of m, and for this to be less than or equal to 0, we have to have these forces that m belongs to in the interval, that is m should be greater than or equal to 1 and less than or equal to 7. So, m should be, more precisely m should be in the interval 1 comma 7. That means for any value in between, and it is automatically this is taken care, the other value, for instance okay, that is m should be greater, m should be greater than minus 9 by 16, that is always taken care by this inclusion, by this condition, and hence for any value m belonging to this interval 1 comma 7, we can always find a x such that mx square plus 3x minus 4 by m plus 3x minus 4x square is equal to y. So, this is the value of, this is the answer to the given problem. Let me now proceed to the Another different type of problem, consider this: two equations, x square plus ax plus a equal to b, where a and b are real numbers, and we know that b is a positive number, a and b are reals, and there is another quadratic equation, x square plus ax plus a equal to minus b. Okay. So, these are the two equations we have, and it is given that the roots of these equations, the solutions of these equations so there are, so this is a quadratic equation, there are two roots possible, here there are two roots possible, and it is assumed that if the solutions of these equations for consecutive integers, this is given. Okay. Say for example, if the roots are 1, 2, 3, 4, maybe 1 and 3 may be the roots of the first equation, maybe 2 and 4 may be the equations of the roots of the second equations. Okay. So, the condition is if the solutions of these equations are 4 consecutive integers, then what are the values of these a and b? Find possible pairs a b. Okay. Hope you have understood the problem. So, we are given two quadratic equation, and it is the only condition I know, this b is a positive number, and if the solutions of these equations are for consecutive integers, then what are the possible pairs a b. Okay. So, how do we proceed this? Now, if you look at this equation, the left hand sides are same, only the right hand side, the first equation it is b, the second equation it is minus b. Now, one thing we can immediately say, what will be the, you look at the first equation, what are the, if alpha and beta are the roots, alpha plus beta will be equal to minus a. The same thing the second equation, the alpha plus if I say some a and some roots, let us say p and q are the roots, p plus q also will be equal to minus a. Therefore, the sum of all the 4 integers, so it is also given that the roots are 4 consecutive integers. So, therefore, the solution, say the solution I proceed like this: the sum of all the 4 consecutive integers because the first two root, the suppose if I say alpha beta and here it is p and q, the solutions will be here, the sum will be alpha plus beta is minus a, p plus q also minus a. Therefore, the sum of all the 4 consecutive integers will be minus 2a. So, this is the first information we have got. Let us say now we have to find the roots, what are the roots explicitly. Now, consider, let the roots be, let one of the roots be n, so if n is a root, the next the other root will be n plus 1. So, I can always assume that n plus 1 is one root, because n is a root, n plus 1 also is a root, and n minus 1 is a root, and we can take n minus 2 also is a root. Assume that these are the 4 consecutive integers, and we have seen that it is equal to minus 2a. Now, by solving this, I can find the value of n. N turns out to be 4n minus, now 4n minus 2 is equal to minus 2a, and hence n becomes 1 minus a divided by 2. Once I know the value of n, I can find the value of n plus 1, n plus n minus 1 and n minus 2. For instance, n minus 1, n minus 2 will be equal to minus a plus 3 divided by 2, and n minus 1 will be equal to minus a plus 1 divided by 2, and n plus 1 is equal to 3 minus a divided by 2. So, we know all the roots of these equations. So, thus the integers are I can write minus a plus 3 by 2 minus a plus 1 by 2, 1 minus a by 2 and 3 minus a by 2. So, these are the roots of the equation. And now look at the equation. Let us for instance, let us take the first equation, x square plus ax. So, the first equation is x square plus ax plus a minus b is equal to 0. So, these are the 4 roots. Now, you see if, some of the roots of this equation is minus a. So, we get so therefore, we have this minus a plus 3 by 2, this is one of the roots, and if I combine with this minus a minus 3 by 2, these are roots of this equation, because if I sum it, or one of the equations are roots of. So, the other equation is this x square plus ax plus a plus b equal to 0. So, these are roots of one of the, because for both the equations the sum of the roots is minus a. Now, if I sum these two, then I get the minus a, are roots of one of these equations, and similarly the remaining will be the roots of the other equation, that is minus a plus 1 and minus a plus 1 by 2, this minus a minus 1 by 2 are the roots of the other equation. Is clear? Next, I look at the products of the roots. For example, if I take the product, and I cannot say whether it is a minus b or a plus b, but I can sum it up. For instance, if I take the product minus a plus 3 by 2 and I take minus a minus 3 by 2, then I take the sum minus a plus 1 by 2 minus a minus 1 by 2, this has to be equal to the sum of a minus b plus a plus b, which is equal to 2a, is equal to 2a. Hence, now if I sum these, it reduces to, that is a square minus 4a minus 5 is equal to 0. One can verify that this, if I simplify this, I finally get this a square minus 4a minus 5 is equal to 0, which gives the value of the a. Is that a turns out to be minus 1 and 5. These are the possible values of a. Now, if I take a is equal to minus 1, this gives a square minus 4 is equal to a minus b, which gives the value of b is equal to 1. Similarly, if a is equal to 5, this gives b is equal to again the same value 1. Therefore, the possible values, the possible pairs are minus 1 1 and 5 comma 1. So, these are the only possible pairs, so that the given condition is satisfied, that is if the solutions of these equations are for consecutive integers. Now, I move on to the next problem. Let us solve it. It's not a, it's as such it is not a quadratic equation, but we can solve it using quadratic equation. So, this is the problem. Solve for real solutions of the equation 2x plus 1, 3x plus 1, 5x plus 1, 30x plus 1 equal to 10. So, if this is a product of every linear term, finally it is a 4th degree polynomial in the left side. So, naturally it is difficult to solve, but if I combine the first two terms and the say 3rd and 4th term, then I get a quadratic equation, then I can factorize. For instance, if I combine the first two terms, I get 6x square plus 5x plus 1, and the 3rd and the 4th term if I combine, then I get another quadratic equation 150x square plus 35x plus 1 equal to 10. In case the right hand side is 0, then I can simply factorize this, I can find the solution using the formula. Similarly, I can find the value for x, then I can simply say that these are the solutions of, I can find the real solutions, the problem is over. But the right hand side is not equal to 0 here. So, there is no point, then there is no clue here, there is no connection between the first factor and the second factor, first term and the second term. So, this type of grouping and writing this as a product of two quadratic expression will not be of any help. So, what do? I do not go by this procedure. Okay. What I do is, there is another method, I combine the first term and the 3rd term and the second term and the 4th term. For instance, 2x plus 1, 5x, a small term and small term in the last two terms. This is one group. Another group I have 3x plus 1 and 30x plus 1. What is the magic? We will see now. It is equal to 10. Now, when I take this first two terms, now it is simply a quadratic expression, namely 60x square, first term, I am sorry, first term and the last term, 30x plus 1 and 3x plus 1 into 5x plus 1. This turns out to be 60x square, yes, nice quadratic expression, 60x square plus 32x plus 1, and similarly the other quadratic expression will be 15x square plus 8x plus 1 equal to 10. Now, you can see the connection between the first quadratic expression and the second quadratic expression. If I multiply this by 4, then it becomes 60x square and 32x. So, therefore, that is giving me an idea. So, what I do is I multiply and divide by 4. So, this becomes 60x square plus 32x plus 1, again 60x square plus 32x plus 4 whole divided by 4, and 4 I am just taking it to the right side, it becomes 40. Okay. Now, you can give a substitution, put y is equal to 60x square plus, put y is equal to 60x square plus 32x. So, this gives, simplifies our equation, that is y plus 1 into y plus 4 is equal to 40, where y is equal to 60x square plus 32x. Now, I solve for this y, then if I simplify this, it becomes y square plus 5y minus 36 is equal to 0. This gives, the solutions are y is equal to minus 9, 4. If I take y is equal to minus 9, okay. So, we have to go back to the original variable. if I take y is equal to minus 9, the equation become the expression becomes, that is 60 x square plus 32 x plus 9 is equal to 0. So, they simply we have this quadratic equation, and solving this quadratic equation, and remember this obviously since all thirds b square minus 4ac will be definitely it will be negative. Okay. Here for this the b square minus the discriminant will be negative, therefore, there is no real solution, hence no real solution. So, now let us check with the other value y equal to 4. The given equation becomes 60 x square plus 32 x minus 4 equal to 0. So, this gives obviously b square minus 4ac is greater than 0, and hence I get two solutions, real solutions, namely x is equal to minus 4 plus minus square root of 31 divided by 50. Right. So, what we have done is, so initially the grouping is very important. Instead of grouping in the usual consecutively, then if I group so that the first term, the first factor with the largest factor of the next pair, and similarly the larger pair with the in the first pair with the smaller one in the second pair, then in that case I get a connection between the first quadratic expression and the second quadratic expression, and then simply afterwards it is all routine. Okay. So, let us see another different type of problem. Consider this equation x minus a, it is very, it is a, as soon as you need not solve this problem, but as soon as you see look at the equations you will be able to tell the answer. X minus a, x minus b, okay, a and b are real numbers, x minus a into x minus b is equal to c, a, b, c are real numbers. With this given that c is not equal to 0, c is not equal to 0. That means for this expression a and b are not the solutions. If alpha and beta are the roots, okay, they cannot be a and b. If alpha and beta are the roots of this equation, what are the roots of this equation? That is x minus a into x minus b plus c equal to 0, x minus alpha, x minus beta plus c equal to 0. It is given that alpha and beta are the roots of this equation, and we have assumed that c is not equal to 0. Now, we are interested in finding the roots of this given equation. Okay. Now, given that, what is given? Let me rewrite what is given. Given that x minus a, x minus b minus c is equal to, let me take this c to the left side, and the coefficient of x square is 1, remember, therefore, and it is given that alpha and beta are the roots, therefore, I can write factorize like this, x minus alpha, x minus beta. Okay. Now, again if I rewrite this x minus a, x minus b, if I take the c to the right side, x minus alpha, x minus beta plus c. Now, we look at this second equation, the given equation x minus alpha, x minus beta plus c. For this equation, if I am able to write these factors as a product of these two linear factors, then immediately we can conclude that a and b are the roots. The roots are a and b. Okay, so that is what I said. So, without solving the problem, by looking at this we can immediately you will be able to conclude that the roots are a and b. Now, let me take the same way I can consider one more problem. Consider this equation. X square plus bx plus c, x square plus bx plus c is equal to 0. And here I assume that alpha and beta are the roots. Given alpha and beta are the roots, and also there is a condition alpha is less than beta, and also this the number c is a negative number, that is c is less than 0 and b is greater than 0. So, these are the information given for this equation x square plus bx plus c equal to 0. Alpha and beta are the roots, where alpha is less than beta and c is less than 0 less than b. Then the question is this: show that alpha is less than 0 less than beta less than mod alpha. Okay. So, how do you proceed? The solution. Given that c is less than 0, c is negative. Therefore, the product of these roots, that alpha beta is negative. Alpha beta, because c is negative, therefore alpha beta is negative. That means alpha and beta, one of them is negative. One of the roots, that is one of the roots is negative. Also, see that what is alpha plus beta? Sum of the roots is equal to minus b, which is also, because b is positive, it is given, so which is also negative, which is also negative. If also it is given alpha is less than beta, therefore alpha is less than 0, alpha is less than beta, therefore alpha is less than 0 and beta should be greater than 0, then only the product will be negative. And since alpha plus beta is also negative, then automatically, since alpha plus beta is negative, automatically this mod alpha will be should be greater than beta. Now, we have shown that, that is alpha less than 0, which is less than beta, and beta is less than mod alpha. Okay. This is one of the problems I have seen in JEE paper earlier. Consider this equation: x minus a Tx minus b equal to 1. Assume that a is less than b, it is given. If alpha and beta are the roots, if alpha and beta are the roots, now prove that the a and b prove that A and B lie between alpha and beta. How do we proceed? And now look at this given equation, that is P of, let P of x be the given quadratic expression. Let P of x is equal to x minus a, x minus b minus 1. And if I simplify this right hand side, it is simply x square minus a plus bx plus ab minus 1. Okay. So, P of x is equal to 0 implies x square minus, this is the P of x, x square minus a plus b x plus a b minus 1 equal to 0. This gives, if I consider this quadratic equation, the discriminant, if I look at this discriminant b square minus 4ac, that is d becomes a minus b whole square plus 4, which is always greater than 0, and also the coefficient of x square, okay, coefficient of x square is equal to 1 and also it is greater than 0. Therefore, this equation has two real roots. So, the equation, the given equation, so therefore, the given equation has two distinct real roots. So, therefore, the graph will be something like this. If this is the x axis, then the graph will be something like this. So, this is my alpha, let us say alpha is less than beta, okay, and the graph will be something like this, has two real roots. And remember, if you take in this, on this region on the real line, the function will be always positive, and on this part of real line the function will be again non-negative, whereas it is negative only in this region between alpha and beta. So, that is the nature of the graph of this equation P of x. Now, note that P of a, if I find the P of a, this is negative because P of a is minus 1. Similarly, P of b is also negative. Therefore, and remember the function has a negative value only in between alpha and beta. Therefore, a and b must lie between alpha and beta. So, a and b, since already we have assumed a is less than b, so the first one can be a, the other one will be b, must lie between alpha and beta. Okay. So, okay. Next I move on to the, so another type of problem. Consider this 7 plus, it is not a quadratic equation, but this can be reduced to a quadratic equation. 7 plus 4 root 3 whole to the power x square minus 5x plus 5 plus 7 minus 4 root 3 whole to the power x square minus 5x plus 5 equal to 14. So, this is the equation we have and we have to solve for x. And naturally we have to give some substitution, so that it reduces to a simple quadratic equation and we can solve it. So, I give the substitution. Now, remember, note that we have to note certain things here. 7 plus 4 root 3 into 7 minus 4 root 3 is equal to 1. That means 7 minus 4 root 3 is the inverse of, that is 7 plus 4 root 3 whole inverse. So, this is the observation, and with this I can put a substitution, put y is equal to 7 plus 4 root 3 whole to the power x square minus 5x plus 5. Then this is simply, the given equation becomes y plus 1 by y, this is 1 by y because 7 minus 4 root 3 is 7 plus 4 root 3 whole inverse. So, 1 upon 7 plus 4 root 3. So, y plus 1 by y is equal to 14. It is a simple quadratic equation, that is y square minus 14, that is y square minus 14y plus 1 equal to 0, which gives the solution y equal to 7 plus 4 root 3, again 7 plus 4 root 3 and other root is 7 minus 4 root 3. So, y equal to 7 plus 4 root 3 gives, that is 7 plus 4 root 3 whole to the power x square minus 5x plus 5 is equal to 7 plus 4 root 3 whole to the power 1. So, this forces that the numerator, the power x square minus 5x plus 5 is equal to 1. Similarly, by taking 7 y equal to 7 minus 4 root 3, this gives my other equation, namely x square minus 5x plus 5 equal to minus 1. So, and by solving these equations I get the solutions x is equal to 1 comma 4 and this is 2 and 3. So, therefore, the solutions are one, 2, 3 and 4. Now, altogether I move on to a different type of problem which you might have seen in many question papers. This is about the common root of a quadratic equation, okay. Common root of a quadratic equation. Consider this quadratic equation, namely a1x square plus b1x plus c1 equal to 0. And one more quadratic equation, let me consider a2x square plus b2x plus c2 equal to 0. Fine. Next, the common roots. Suppose if alpha is a common root, if remember if alpha is a common root for both the equation, then we have the equation simply a1 alpha square plus b1 alpha plus c1 equal to 0 and a2 alpha square plus b2 alpha plus c2 equal to 0. Okay. Now, if we solve for this, now the condition you see by the Cramer's rule, you have seen the condition like alpha square is equal to b1 c2 minus b2 c1 equal to minus alpha divided by a1 c2 minus a2 c1 is equal to 1 divided by a1 b2 minus a2 b1. So, this implies alpha is equal to a2 c1 minus a1 c2 divided by a1 b2 minus a2 b1. Similarly, other alpha is equal, this is equal to b1 c2 minus b2 c1 divided by a1 c2 minus a2 c1. So, this is the, if alpha is a common root, then it is necessary that the common root has to satisfy this condition. If both the roots are common, suppose assume that if alpha and beta are the roots of the first equation and also the second equation, okay, then what happens is one equation is the constant multiple of the other. One equation, if both the roots are common, it is necessary that both the one equation is the constant multiple of the other equations. So, in this case we have a1 by a2 is equal to b1 by b2 equal to c1 by c2. Okay. So, these are the conditions for b1 by b2. So, now let us take one simple problem to find the based on this common root problem. Consider this small example, x square plus px minus 1 equal to 0, and the other equation is x square plus x plus p equal to 0. So, directly one can use this condition or directly you can solve the given two equations. So, it is given that let these two equations have a common root. Then find the value of p. What is p? If these two have a common root, what is the value of the p? So, by using this condition, we can see that 1 plus p, the condition what we have, one plus p whole square is equal to 1 minus p into p square plus 1. Minus p into p square plus 1. So, this gives p square plus 1 plus 2p and p square plus 1 minus p cube minus p, which gives 3p equal to minus p cube. So, this implies p is 0 or plus minus I root 3. So, these are the possible values of p, and the same way let me give one more problem. Consider this quadratic equation, x square minus lambda x minus 21 equal to 0, and another equation is x square minus 3 lambda x plus 35 equal to 0. The same procedure you can adopt. If they have a common root, find lambda. So, by using the same method you can show that lambda is equal to plus minus 4. Okay. I leave it to you as a small exercise. Then next I go on to the another problem. Consider this problem, x square plus 2x plus 3 equal to 0 and ax square plus bx plus c equal to 0. These two equations have a common root, if have a common root. Only one common root. Then in that case, what can we say about the ABC? So, what is A is to B is to C, and by looking at this first equation x square plus, that is the explicit equation, this totally the variables are unknown, the coefficients are unknown, x square plus bx plus c equal to 0. So, in this case the first equation, by looking at the first equation we see that the discriminant b square minus 4ac is negative, therefore, both the roots are imaginary roots. So, the roots of the first equation x square plus 2x plus 3 equal to 0 are imaginary, no real solutions. Therefore, and if alpha plus I beta is a root, alpha minus I beta also is a root. Okay. Similarly, if these equations have a root, have a common root, then this ax square plus bx plus c also have the this forces that ax square plus bx c equal to 0 also have the same roots, that is both roots are common to these two equations, and hence the second one of the equation is the constant multiple of the other equation. So, therefore, what we have is a by 1 is equal to b by 2 equal to c by 3. So, therefore, a is to b is to c is equal to 1 is to 2 is to 3. Okay. And finally, let me give one more problem on this common root quadratic equations. Let us say a is not equal to b, x square plus ax plus b equal to 0. Another equation is x square plus bx plus a equal to 0, and assume a is not equal to 0, a is not equal to b, sorry, if a equal to b, this is only one equation we have. If a is not equal to b, and also it is assumed that they have common root. If these equations have a common root, then what is a plus b? What is the value of a plus b? So, obviously, if I subtract these equations, immediately I can find out, that is a minus bx plus b minus a is equal to 0, which forces that x is equal to 1. If x is equal to 1, then automatically substituting in one of the equations, for instance x 1 plus a, so this implies 1 plus a from the first equation, 1 plus a plus b is equal to 0. So, therefore, a plus b is equal to minus 1, and let us see in the next lecture. Thank you.